Hello, 8th grade, and welcome to your first math review of the year. All right, so we are going to go over the answer key. So make sure that you have everything correct. If you have any questions, double checking your work. All right, so let's start with question number 1. So it says there's still a controversy about whether or not Pluto should be considered a planet. Although planets are mainly defined by their orbital path, the issue of size is something to consider. The table below lists the planets, including Pluto, and their approximate diameter in meters. So on the left, we have all of the planets. On the right, we have all of their sizes, again, in meters. So we're going to name the planets in order from smallest to largest. So if you remember from the other day, one thing we had to look at was the exponents. So here we're going to compare the exponents to see which one's the smallest and then go to the largest. So I'm seeing exponents of 6, 7, 7, 8, 8, 6, 7, 7, 6. So let's start with 6. 6 is the smallest. So I have Pluto at 2.3. I have Mars at 6.79 and Mercury at 4.88. So Pluto is going to be first because out of those three numbers, that has the smallest. And then I'm going to look between, next I have Mars and Mercury. Mercury is 4.88 where Mars is 6.79, so Mercury comes next. All right, we're going to check that one off. And then Mars. So next I'm going to look at the ones with 7 as the exponent in scientific notation. So I have Venus, Earth, Uranus, and Neptune. So the values I have are 1.21, 1.28, 5.12, and 4.96. So I have two that start with 1.2, 1.2. The next number from left to right is 1. So Venus would be next. Then Earth. Next, I'm going to come down here and compare these two values. So if I'm working left to right, I have a 5 and a 4, so that would mean Neptune goes next. And then Uranus. Okay, so my last two values that I have are 1.2 times 10 to the 8th and 1.43 times 10 to the 8th. So we both have exponents of 8. Working left to right, I could have a 1 and a 1, 2 and 4. So Saturn is going to be next. And my last one is Jupiter. All right. So comparing only the diameters, about how many times larger is Jupiter than Pluto? So when we're doing this, so we're comparing Jupiter and Pluto. So we're saying how many times larger. So Jupiter is being divided by Pluto. So I'm going to come up and take these values. So Jupiter is 1.43 times 10 to the 8th. And Pluto is 2.3 times 10 to the 6th. So it does say about how many times. So there's two different ways to do this. Most of you I see are going for that exact value, so I'll do that first, and then I'll show you how we did it in class. So when you're dividing these two values, you have to subtract your exponent. So I'm going to have 1.43 divided by 2.3 times 10, 8 minus 6 is 2. So if we divide this, I have 1.43 divided by 2.3. So that gives me, that would give me 0.62 times 10 squared. In order to make this in scientific notation, I need to move this 1 to the right. So this then becomes 6.2 times 10. Since I took away a decimal point, or a factor of 10, I have to take away a factor of 10 here. So that's that way. You can also adjust this since you know that this is smaller than this. So you would, let me find space right here. So you can change this to 14.3 times 10 to the 7th and divide it by 2.3 times 10 to the 6th. So I still essentially have the same values, but now I have a number that actually is larger than this. So again, when I subtract my exponents, I'm going to end up with just a 10. And then if I divide 14.3 divided by 2.3, that gives me that 6.2 already. So this is going to end up being 6.2 times 10. Or the last way we learned it in class is we could kind of estimate these a little bit. So there's not really a great way to do this. You could change this to maybe a 1.5 and a 3. You're still going to have a little bit of issues, so you'd still have to move this. So you could change this to 15 times 10 to the 7th divided by 3 times 10 to the 6th, which would give you roughly 5. Any of these answers, any of these ways are perfectly fine. Just make sure that you're showing your work so that I can follow along and make sure that you're doing it right. All right. C then. Comparing only diameters, about how many times larger is Jupiter than Mercury? So we're going to come up and find Jupiter. Jupiter again is, so we're comparing Jupiter divided by Mercury. So Jupiter is 1.43 times 10 to the 8th. And Mercury is 4.88 times 10 to the 6th. So let's just, let's do it this way. I'm going to do the same thing. So I'm going to change this because this value, if I ignore this right here, this value is smaller, and I'm going to need something that has an actual whole number to work with. So I'm going to change this to 14.3 times 10 to the 7th divided by 4.88 times 10 to the 6th. So I'm going to use my exponent rules and subtract. So I'm going to have some value times 10, 7 minus 6 is 1. And now I can divide these two values. So I have 14.3 divided by 4.88 is equal to 2.93. So you can just 2.93 or 2.9 is sufficient. There we go. There you can see now. All right, next page. Comparing only diameters, about how many times larger is Jupiter than Earth? Ooh, there's not a lot of room here. Sorry, guys. All right, so I have Jupiter divided by Earth. Jupiter is, again, 1.43 times 10 to the 8th. Earth, then, is 1.28 times 10 to the 7th. So in this case, we have a number that is larger than, the numerator is larger than the denominator, so I don't really have to do too much. When I subtract these using my exponent rules, I'm going to end up with 8 minus 7 is 1. So I'll just do these values right here. So I have 1.43 divided by 1.28. This gives me 1.117 times 10 to the 1st. All right. Andrew then wondered how big a planet would be if its diameter was the square of Pluto's diameter. If the diameter of Pluto in terms of meters were squared, what would the diameter of the new planet be? So what you have to do is you have to essentially write this. So Pluto here is 2.3 times 10 to the 6th. So I have 2.3 times 10 to the 6th. And that whole thing needs to be squared. So if you remember from our exponent rules, this 2 needs to go into everything. So I'm going to have 2.3 squared times 10 to the 6th squared. So 2.3 squared ends up being 5.29 times 10. When I raise an exponent to an exponent, I multiply. So 6 times 2 is 12. So your answer then is 5.29 times 10 to the 12th. All right. Question number 2. The number of users of social media has increased significantly since the year 2001. In fact, the approximate number of users has tripled each year. It was reported that in 2005, there were 3 million users of social media. Assuming that the number of users continues to triple each year for the next 3 years, determine the number of users in 2006, 2007, and 2008. All right, so we have 2005, 2006, 2007, 2008. So it tells us right here that in 2005, sorry guys, in 2005 there were 3 million users. Okay, so we have 3 million. So then we essentially need to triple that number. We need to multiply it by 3. So this is going to be 9 million. 9 times 3 is 27 million. And 27 times 3 is 81 million. Okay. Assume the trend in the numbers of users tripling each year was true for all years from 2001 to 2009. Complete the table below using 2005 as year 1 with 3 million. Okay, so we have 2005 down here as the number of years, number of users that year. Okay, so when we're doing this, the best way to do this is to use this row as your exponent. So this would be 3 to the 1st, 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th. If we continue with that, this is going to be the same. So 3 to the 0, 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. So 3 to the 1st does give me 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. And 3 to the 5th is 243. Anything to the 0 power is going to be 1. 3 to the negative 1, remember we have, it flips, so that becomes 1 over 3. 3 to the negative 2, so that would be 1 over 3 squared, or 1 over 9. And then same here. So I have 1 over 3 to the 3rd, or 1 over 27. So that's how this chart should get filled in. So given only the number of users in 2005, so right here, and the assumption that the number of users triples each year, how did you determine the number of users for years 2, 3, and 4? So essentially, all you're doing is you are multiplying the previous year value by 3. All right, then, given only the number of users in 2005 and the assumption that the number of users triples each year, how did you determine the number of users for years 0, -1, -2, and -3? And then a basic way to do that, because you're getting smaller, and I did hear a couple of you say this, you're essentially just dividing by 3. All right, so then for this last page, what you're doing is you're using those exponent rules to determine your answers. So here I have 4/3 times 4 to the 5th. When you're multiplying values with the same base, you add your exponents. So the base stays the same, the exponents we add, so 3 plus 5 gives me 8. Here I have 6/4 divided by 6 squared. When I'm dividing and I have the same base, I subtract my exponents. The base stays the same. 4 minus 2 is 2, so I have 6 squared. Here I have 3 to the 0. Anything to the 0 power is 1. D, 5 to the 1st. Anything to the 1st power, the base stays the same, so that just ends up being 5. Here I have 1 to the 10th power, so essentially just multiplying 1 10 times, so that's just going to be 1 as well. For F, I have 2 to the -2. This again is where you're going to flip that, so that becomes 1 over 2 squared. That is perfectly sufficient for me. For G, I have 7/5 to the 4th power. So when you're raising a power to a power, you multiply. Base stays the same. So that 7 stays. 5 times 4 is 20. All right, and then here, when I have 2 pieces inside and an exponent outside, that exponent gets shared with everything inside, so I have 8 to the 3rd times 9/3. And then same goes for this parentheses right here. So this 5 gets distributed to the numerator and the denominator, so I have 4 to the 5th over 3 to the 5th. And that is your review for chapter 1. Please let me know if you have any questions, if you have any, if there's anything you didn't understand. Remember to bring this with you tomorrow, and good luck.